Srikanth, can you hear me?
Yeah, I can hear you, and I can start. I started recording as well.
Okay, fine. So
Sometimes
we're just click on that record this meeting session, this meeting here at the bottom of the screen. You see that?
record this meeting. This session is
Yes.
being recorded. Yeah.
That's what. Just click on that, it will say. So today we are going to see the introductions. Introduction is nothing but we're going to see the basic things here on the about the Linux. So Linux is an operating system developed by a person called Linus Torvald in 1991, and it is a combination of GNU application and Unix kernel. It's a combination of GNU application and Unix kernel. You know what is GNU? GNU stands for generally not Unix applications. Understand? So it's a combination here. And when we talk about Linux, there are so many flavors of Linux that you can find in the market, like Red Hat Linux, CentOS, Ubuntu. Okay, like this we have Fedora. There's so many types of Linuxes we can find. But you know, in this, like we have something called open source operating system, we have something called closed source. So when I talk about Red Hat Linux is not open source, of course you can just go to the site and you can register yourself with a domain ID. So when I say domain ID means if you're working with some company, if you have some university student IDs, with that when you register and Red Hat will approval that ID and they will give an approval within 24 hours to download the operating system, right? So but when you download it, it is on 60 days evolution copy. It is not a lifelong copy it is. Of course you can use it, you can install it, you can work on that, but you know, like we will not get a support after 60 days. Okay, but when I talk about CentOS, SUSE, Ubuntu or Fedora, these are all open source operating systems. So open source means even no need to pay even a $1 also to them. Okay, 1 rupee also. So we can just start using it and download it and start using it. Okay, but as I told you, right, open source operating systems are not used more in the real times because of support. Because we need to provide some support, right? Because if you have any problem, the vendor has to provide me support. Okay, for all the problems I can't provide solution. If there is a bug in operating system, only vendor has to fix that, not myself, not an administrator, right? So that's the reason if a vendor doesn't have that much technical team to provide that support, then it will be a problem to the project. Okay, business loss, business impacts will be there. Okay, so that's the reason it is not recommended to use these open source operating systems in real-time projects. It is only used for testing and some R&D, research and developments, and the testing projects will be there, and the development projects will be there. So it is majorly used. Okay, and apart from this, we also have a Unix. When I talk about Unix, we have a Solaris operating system. Solaris is previously it is called Sun Solaris, but Sun the company that was undertaken by Oracle, and it is right now called Oracle Solaris. Okay, and we have a company called IBM AIX and HP Unix. These are all the Unix flavor operating system. It's totally commercial. It is not like Red Hat, and it is very costly also. And all these operating systems only operates on proprietary hardware. Okay, so proprietary means, you know, Linux you can install on your laptop, you can install on your desktop, you can install on virtual machines, cloud, everywhere you can do it. But when you talk about this Unix operating system, they have their specific hardware. Without that hardware, you can't install, you can't run that operating system. Understand? And it's very expensive also compared to Linux. And this is all the information. Now we are going to discuss the principles of Unix. And don't confuse here because we are discussing from the basics. Basics is common to the Unix and Linux. Understand? Because if I'm taking a terminology called Unix, if I'm taking a terminology called Linux, don't confuse you. Because whatever the basics we are going to discuss, all these basics are common between the Unix and Linux. Right? Getting it? and you know, because already we discussed, Linux came from the Unix only. For always the people will say Linux is Unix-like operating system. Linux is Unix-like operating system. So there is a reason behind this, because Linux has been brought from the Unix. That's the reason it is called like this. Okay, and when we talk about the Linux or Unix, it treats everything as a file. It treats everything as a file, right? So when I say it treats everything as a file, file as a file, directory something for folder as a file, and even device. So what do you mean by device? Hard disk, CD-ROM, tape drive, printer, or scanner, or you connect any kind of storage, everything treated as a file. Okay, but we will get a doubt. Why? Why everything is treated as a file? Yes or no? If everything is treated as a file, why it is treating it? Okay, there should be some reason, right? See, basically, when we connect any physical device to the server, okay, so what happens exactly? Okay, for example, you're connecting a pen drive to your laptop. What happens? What it will say? First, it will say the new hardware found. It will give some vendor name, right? After a few seconds, it will say that devices are updating or installing. After a few seconds, it will say that device is ready to use. But exactly what happening in the background to make it ready? So when the device is connected, there will be some auto run program will be there. Auto run program's job is to scan the new devices. Okay, it scans the new devices, it collects the information of the device, and it will match that device information with the operating system. Okay, so basically we will call operating system in Windows, but in Linux or Unix it is called kernel. It is something called kernel. So basically when it comes to Windows, the operating system is going to match that device information. If the device driver is there with this operating system, it will try to load it automatically. When it loads, then the device is ready. Then we can start using it. Right. But when it comes to Linux, we don't have such a kind of auto program. Auto run programs we don't have. Right. So we need to run some commands to detect it. Okay, so when it detects that particular, the command will go and scans the devices, and it will find a new device, and it will match that device information with the kernel, and the kernel is going to load the device driver, right? Then the device is available. But when the device is, the kernel is going to update the device drivers, right? When it updates the device drivers, this device driver is going to generate one logical name for the devices. It is going to generate one logical name for the devices, and that logical name is like this. For example, I'm having a disk with a name called SCSI disk, or a SATA disk I'm having. It is named as SDA or SDB. Because I'm having two disks, it is named as SDA and SDB. Okay, if I'm having a 4 disk, it is named as SDA, SDB, SDC, SDD, right? So with this name, it is going to generate one logical file, and that logical file is going to store where? In /dev. Dev is a directory where it stores all the logical files for the physical devices that is connected on the machine. And these logical files are generated in this location by the kernel by loading the device drivers for the respective device. Understand? So whenever you want to access the physical device, for example, like you want to create one partition, you want to access some disk. So basically we will go to the /dev directory and we will access that particular disk name. That is called SDA or SDB or SDC or SDD. Because if you want to really create a partition, you should understand one thing. What is that? Which partition, which disk will fulfill your partition requirements, disk space requirement. Based on that, you will create. Understand? So this is a very, very important thing, right? So this is the things, right? And the configuration data is stored in text format, in form of text. So what is this? Configuration files are stored in form of text. So you should remember one thing: when you are when it comes to the Windows, take an example. Okay, all the configuration files are stored in binary or encrypted format. It is going to store, right? Getting it? It is going to store in encrypted format. Okay, so when I say it is going to store in encrypted format, it is going to store in encrypted format. That means you can't read it. You can't read it. Getting it? You can't read that particular file. Okay, so that is nothing but encrypted. But when it comes to the Linux, and Unix, all the configuration files are stored in a form of text. All configuration files are stored in text format. Because it is stored in text format, because it is going to store in text format here. Okay, so you can just read it and you can just understand the information. Clear? Understand? So this is the way how it is going to work. Understand? Okay, and it is a small and simple purpose program. So like you know, in Windows we will be putting C, C++, right? C and C++ programming or Java programming or HTML programming, we will be installing and we will be configuring it, right? So, but when we talk about Linux, Linux has so many programming languages. Linux has so many programming languages. So, like it has a programming languages with the name called shell scripting, Perl scripting, Python scripting, because Linux and Unix are having so many shells. Like you know, for example, when we talk about Linux, the default shell inside the Linux is Bash shell. When I say what is the default shell inside the Solaris, it is nothing but Bourne shell. Okay, and when we talk about AIX, it is Korn shell. So every operating system is having its proprietary, its own shell. Okay, it is having its own shell, right? So once apart from this own shell, you can use any other shell also. For example, in Linux, I'm using Bash shell, right? So apart from this Bash shell, you can use Bourne shell, Korn shell, or any other shell that's available. Okay, so basically this shell has a programming capability also. We can write the program inside the shell. Understand? So this is advantage about the programming capabilities, right? And Unix is the operating system. It converts human readable language to the machine readable language, machine readable, and vice versa. Okay, and OS is a collection of software and program. And software, you know what is software? The program and other operating system information used by the computer is nothing but software. And you know, program is nothing but set of instructions. And to perform a specific task, we are going to do program. And you know, we have a talking about operating system. We have two types of operating system. One is single user operating system. Another one is multi-user operating system. When I talk about single user, that is nothing but one user can access the system resources in a single user. So for example, like you know, system resources means CPU, memory, disk. This all comes under single system resources like Windows 95, Windows 98, DOS. This all comes under the single user operating system. And we also have a multi-user operating system accessing multiple users. That is nothing but you know, for example, Unix and Windows server-based operating systems all comes under multi-user operating systems. So that means one machine, one hardware can be accessed by many people. So I can connect the server from here, you can connect the server from your place. Okay, so there will be hundreds and thousands of people will be connecting to the server and they will be performing their task. That is nothing but multi-user. Okay, so this is all about the single user and multi-user. Now we are going to discuss the Unix features. So when I talk about Unix features here, so multiple users access the system resources is known as multi-user operating system. And when I talk about multitasking, task, you know what is task? Task is nothing but a job. Job is nothing but a process, and process is nothing but again a task, right? So multitasking is nothing but you know when The people are logging into the machine, they definitely they do multitasking. I will create a file, I will open some directory, I will do so. Right now you can see that multitasking. Even right now my machine is multitasking because I'm opening a browser, I have opened a notepad, I am just talking on the GoToMeeting. So it is all multitasking, right? So these are things happens. And when I talk about task, there are two types of process. One is foreground, another one is background. One is foreground, another one is background. So when I talk about foreground, that is nothing but the process that runs in front of us, that is nothing but foreground. And background is nothing but the process that runs in back. Backend means, what is that? So basically, you know, when we open a task manager, there will be so many services running here. So did we start this all services here? No, we didn't start any of these services. This all services got started at the time of system power on. So basically we didn't power on it, we didn't made it online. So these all services are called background. Understand? So it comes online when you power on the machine, and it goes off when you power off the machine. Okay, and when we talk about foreground, what is foreground? Okay, so foreground means if you run in front of this prompt, that means when you log into the server as a normal user, you will be getting a dollar prompt. When we log into the server as a root user, we get a hash prompt. Okay, so when you're running any task in a front of this dollar prompt or a hash prompt, it is running in front of you, that is called foreground process. And we are going to discuss something about security. In order to secure the data and systems from other users and networks, we need to provide security. Like, you know, in Windows, we will put antivirus or firewalls, right? So at the same time, Linux is also having some sort of security, or Unix is having some sort of securities. Okay, and basically the security is divided into two: hardware level and software level. So what do you mean by hardware level? How do we secure it? So basically in real times you will see rack mounted servers. In real times we will see something called rack mounted servers. The servers will be placed in one rack. Okay, and they will be physically locking it. Okay, so such is nothing but hardware level security. And apart from this, you know, every machine will have something called BIOS, basic input output system. Before you install operating system, we will get into the BIOS. So when we talk about a BIOS, putting the password to the BIOS is nothing but hardware level security. And we have something called software level security, that is called login level and FAP. Login level is nothing but you know, you may log into the Windows or Linux or any other operating system. We need to put username and password. Without authentication, there is no login access, right? So why specifically in Linux and Unix it is we are saying login level? Because there is one reason. What is that reason? So when you're putting a password in the Windows, it is going to show that password strength in putting some asterisks, right? With this, we can just analyze, yes, boss, his password is 8 characters. Now I will start guessing the password. Okay. Now, when it comes to Linux, the password screen will be a blank screen. Even it will not print a single character there. Okay, there is nothing but login level. And FAP stands for file access permission. So when I talk about the file access permission, that is nothing but, so like here you know that every file, okay, so every file will have every directory, and every file will have some kind of permissions. Some kind of permissions we have, that is called FAP, that is called file access permission, like read, write, and execute permissions will be there. So okay, and apart from this, we also have some advanced level permissions, that is called sticky bits, setUID, setgid, ACLs, and sudo, RBACs. These are all advanced level permissions that we will be discussing in administration. And apart from this, we have a concept called communication. Like, you know, we are using something communication like Gmail, Gtalk, or we are using something called Google Hangout. So when I say Google Hangout, it only works online. So other side user is online, then only you can do Hangout. Otherwise, no. Mail means even the user is online or offline, you can just send a mail. It will be stored in his mailbox or inbox. Then when he comes online, he will be looking at. So, but when you go to the Linux and Unix, we used to see this communications. Nowadays, no one is using. Okay. So, and we have a concept called help. You know what is help? In Windows, we have a concept called help and support. We have a concept called help and support. So when I say help and support, here in Linux, in Unix and Linux, we have a concept called man. So man is nothing but it's a command that helps us in getting the information from the system. Okay, so get help from the operating system is known as help, and we have a man command to get help from the operating system, and you have to run this command like this: man followed by the command name. And following basically the man page contains 8 sections here. So this is all the 8 sections what we have. So general command, system call, C library functions, special files. It's all the 8 sections that you're going to see. Okay, so basically as administrator we are very much we will be getting more information about the 8 section that is called system administration command and daemon, and we can also know information with this also. Okay, but how do we know that commands belongs to how many sections? We have to use a command called what is followed by the command name that gives you the how many sections this command is going to provide us help. And if you want to read a specific section, this is the command syntax how we are going to use it: man followed by the section number and followed by the command name. Okay, so this is the way how it is going to work. Any doubts here?
No. So
Okay,
yeah.
so this is the way. And apart from this, we are going to discuss something about architecture of Unix and Linux. Okay, so when I say architecture, most of the people they get confused how really operating system is going to work. That means when I'm running some command, how it is working. For example, in Windows, you'll double click with the mouse, a file gets open. If you double click with on a folder, the folder gets open. Right? Anything if you want to do, we are just going to do double click or right click. Okay, so the things will work because it's all programs, right? But even in Linux, so how you're going to work? Because as I told you, Linux is, as administrator, we are going to work on Linux, and it can be totally configured based on command line only. You never see graphics on Linux. Of course, it has a very good graphic environment. I'm not saying it is not having. This is a graphic environment that you can see for Linux. Can you see this? This is an environment. It has a very good environment. Even Windows also you will feel somewhat this thing, but it has a very good features here. Okay, it's very user friendly even Linux, but we never access the machine in this environment with the screens. So we will be connecting this machines with the help of these tools. You see this putty. Okay, if you have to put the IP address of the particular machine, because every machine will have an IP address. So I'm going to use SSH, and I will just say open. Now it connects. You can see it is asking a login prompt. So I'm going to give you a login prompt here as a root, and you can put the password, and you can start connecting, and you can access it. Understand? So this is the way how it is going to work. Okay, you can run any command because I logged in as a root. I'm getting a hash prompt. If I switch as a user, then I will get a user prompt. So right now I'm having a user with a name called Kumar here. So I'm going to switch as a Kumar. You can see I logged in as a normal user. So in real time, you're going to use these tools only. Your server may be any corner of the world. Wherever you sit, you can start connecting that machine. And you can perform whatever the task you want to do it. That means it may be troubleshooting, it may be installation. Installation means not OS. Even OS installers also we can do it. That is a different scenario. And configuration, troubleshooting, everything we can do from here. Okay, understood, right? How this tool is going to work. But when you are running the commands, how this is taken, how it is going to work. Let me give you the information. Take an example. I'm just putting one small diagram here. So to show you how this operating system is going to work. So okay, so I'm having something here. So I'm having something user. You have something called shell. Hardware is nothing but CPU, memory, disk, and network. This is how it's going to happen, right? So basically, we are aware of who is a user because we all come under user category, right? And what is hardware? You know, physical hardware. Without hardware, there is no machine. So hardware means CPU, memory, disk, network, all these things it will contain. Now we should know very well about what is this shell and kernel. So when I talk about shell, you know, when it goes to the Windows, you have a start button, you have a right click, you have a task manager, you have a what we say, notice bar, you have my computer, my documents, right? So without this, can we work with Windows? Even right click doesn't work, it's a big problem for us, right? So at the same time, when I talk about Linux and Unix, without a shell, you can't run even a single command. Without a shell, you can't run even a one single command. The shell is like a interface. Okay, shell is nothing but an interface. It is a command checker. Okay, getting it. So whatever the command you're going to run, we are going to run on shell only. Okay, so now what happens is when I talk about the users, basically we have two types of users. One is normal user, another one is root user. Okay, when I say normal user, we have a dollar prompt. When we talk about a root user, we have something called hash prompt. We have a dollar, we have a hash, right? But whenever I talk about users, and I have to give you some information about the commands also. We have two types of commands. One is normal user commands. Other one is root user commands. When I say normal user, it has been located somewhere in bin. And when I talk about root user, it is located somewhere in bin. Okay. So this is the locations where it is going to maintain the commands. Okay, bin stands for binaries, sbin stands for super binaries, right? But here the question is, when I am running some command, how my shell know that it has to look in bin or sbin? Yes or no? Because shell is going to look into environment variables. Okay, and this environment variables contain the path of bin and sbin. That is called command location, command path. So based on the privileges, the shell will interact with the environment variables and it will go to that particular location to locate that command. Okay, getting it? So this is a very, very important thing. And when it locates the command with the respective options, okay, right? Okay, and it is going to send this information to the kernel. What is the purpose of kernel? Kernel is nothing but operating system. What is the purpose of operating system? It converts human readable to machine readable and machine readable to human readable. Okay, so when it converts human readable to machine readable, it will pass this information to the hardware. 1 minute. Okay. So now what happens? You know what is kernel? Kernel is nothing but operating system. So basically, you know the major purpose of operating system, it is used to convert human readable to machine readable. And once it converts a human readable to machine readable, not only that, kernel performs so many operations. Okay, and it converts readable to machine readable and goes to the hardware. And hardware level, it processes everything, and it after processing it again, it will go to the kernel to convert the machine readable to human readable, and just puts this information to the user. So this is the way how this shell and kernel is going to work. And don't you have to remember one thing: kernel and shell together is operating system. Kernel and shell together is called operating system. Right? Getting it? So this is the way how it is going to work. Okay. So don't forget, I just given you differentiation between shell and kernel to understand easy. But if somebody asks you, kernel and shell is nothing but together is called operating. This is a two layers. This is an operating system contains two layers. Okay, getting it. So this is all the information how it is going to work. And let me give you some more information here. So we're going to discuss something about shell. So shell is a working environment for a user. Without shell, you can't run even a single command. And you know what is the default shell inside the Linux? A default shell inside the Linux is bash shell. So how do we know that it is a default shell inside the Linux is bash? How do we know that? So echo dollar, when I just run this, it is going to give you that the default shell inside the Linux is bash. Okay, and when I talk, shell is an interface between the user and kernel, and shell is an interpreter, and shell is a command checker. And shell is built in with C language, and many shells are there in one operating system. This is all the different shells what we see. And shell has a programming capability. Due to shell, Unix has more features. Unix has more features. This is the things. And types of shell when we talk, so these all types of shells: Bourne shell, C shell, and enhanced C shell. Okay, bash shell, Z shell, Korn shell, these all things. So how do we know that how many shells the Linux is going to support? There is a file called etc shells. These are all the shells the Linux is going to. You can use any of these shells, and you can start working with them.
So what
Okay.
are the difference between all these shells? What are all the difference
I
between?
didn't get you.
We got different
What are the
differences like
these things that when you get into the shell scripting, you will understand that.
okay.
Okay. So every shell has a lot of information, because for example, if I want to tell you a bash shell is there. Bash shell, if I talk about all these shells, bash is a user-friendly shell. So why we call bash as a user-friendly shell? Because just now I ran so many commands. If you just put up arrow, you are able to see all these commands,
Okay.
right? So it has a concept. It has a concept called history. So it is going to maintain this history for 1,000 commands. Okay, but you know in real times it is not safe, because I'm going to perform some task and you are able to see all my commands by putting an up arrow. It is not safe, right?
Yeah.
Yes or no? Right. So like people, when it comes to Linux, of course we are using bash, but when you go for other flavors of Unix, like Solaris or AIX or HP Unix or some other flavors, we never use bash.
But I got it out even in
Okay.
uh,
Yeah, yeah.
yeah, if we enter command history, so all the commands whatever we have.
Yes, yes. Only for bash only you will see that. Only for bash only we have that feature, not for other commands.
Now, just now you said it's so in real time we are not going to use this bash shell or what?
I didn't get you. For
In real time we do use this bash shell, right?
we in Linux it is default we will use,
Okay, in real time I'm asking.
but when it comes to Unix, real time we will use. That's what I'm telling you, right?
Mm-hmm.
In Linux, the default shell is bash. We never change the bash shell.
Okay.
Okay, but when you're talking about Unix, okay, when it comes to Unix, we never use bash.
Okay.
And it is not mandated that I have to use bash only in Linux. If my client will say that, boss, don't use bash shell. Okay, when I'm creating a users, don't give bash shell for users. You will ask me to give you something called Korn shell or C shell or Bourne shell. Understand?
Yeah.
Very good. So based on that requirement, I have to give you.
Okay.
My client will say that because I'm having a 200 users and they're going to log into my server and they're going to write some C programming. So he will say that don't give bash. He will ask me to give only C program, C shell. Because this C shell is developed with the help of C program. It will be a good compatible for a C programmers. Understand? So like this it is will be there. So based on the requirements, shells will be allocated. If there is no customization, we will go with bash only. If you really have a customization, if you have some specification, definitely we will change the shell. Understand? So this is a thing. And when I talk about kernel, kernel is a interface between the shell and hardware. Kernel is a interface between the shell and hardware, and kernel directly interacts with the hardware. Kernel directly interacts with the hardware, and there is only one kernel for one operating system. It is not like shell where we have multiple shells. We have only one kernel, and kernel is a core of the operating system, and it controls and organizes the hardware. And kernel performs low-level functions like process management, device management, memory management, inter-app handlings, and I/O communication and file systems. These are all the low-level functions that kernel is going to perform.
Okay. Sorry to disturb you again.
Hmm.
If as our client requirement is if they needed us to change to different shell, for example we are using bash at the moment, if they wanted us to change it to C shell, so where all these files will be means and all this.
That's what that we will be discussing in user administration. The customizations will be done in user administration.
Okay, that's fine then.
Okay, when we will be discussing user administration in administration, definitely we will be discussing about all these configurations.
Okay.
Okay, which file we have to change.
Okay.
Okay, either we have to change it with on a file or we can just add it to the users. Okay, how we are going to do that we will be discussing in user administration.
And one more
Right?
small one.
And
Sorry.
yes,
All these commands will be same in all the shells. For example, if it is
all the
commands like whatever we use, basic commands like ls
uh,
and ltr, all this same in all the shells. Is it same?
yes, it is. Maybe some options may change.
Okay.
Some options may not work.
Okay.
See, every command will have A to Z options.
Yeah.
So I will not say that all the A to Z options is same to all the shells. Some shell doesn't accept that option. Some shell will accept.
Okay.
Okay, but there are some common options are there that is supported by all the shells.
Okay.
Okay, if I'm telling you Unix and Linux, the basics is common to Unix and Linux. The core commands, whatever we're discussing, all the commands are same. The basic commands I'm telling you. But with that commands, there will be some flags or we will say some options, and that may change. Sometimes some options, for some options Unix doesn't respond at all, but in Linux there will be a response, there will be some output.
Okay.
Okay, because Unix will say that there is unnecessary, they will not give any output to that particular command. Okay, other reason they just ignore it. Okay, other thing. See, I will tell you there is a lot of difference even in technical. If I wanted to compare, Linux and Unix is having a lot of differences. Okay, Linux means what, you know, they give everything to the people. Okay, but in Unix it's not like it's a proprietary, right? They will make some differences between this. Definitely you can see the differences when you start working with Unix. After this Linux, if you start working with Unix, you will see the differences. Okay, so there's a things, a lot of differences are there. When you keep working with the Unix and Linux, and when you have the skill to observe the things very closely, definitely you will find that differences. Okay, so and when we talk about the kernels, types of kernels, we have two types of kernels here. One is monolithic kernel, another one is microkernel. So when I say monolithic kernel here, so monolithic kernel is a single large process running entirely in the single address space, and it is a single static binary file. And the example of monolithic kernel based on operating system or Linux and Unix. Okay. See, and the Windows and the Mac runs on microkernel. Okay, so what is the difference here? Take an example of Windows. When you're installing Windows, Microsoft is providing everything with a Windows operating system? No, right? When you install Windows operating system, you have to install driver, you have to install MS Office, you have to install antivirus, you have to install firewall if needed, right? You have to install Acrobat Reader, you have to install some players, you have to install some games wanted, right? So what it is happening here? That means basically the operating system doesn't require MS Office. The operating system doesn't require Acrobat Reader. Yes or no? Right. But who needs this? User needs this. That's the reason, okay, it is something called microkernel. And it is divided into two spaces, user space and kernel space. Kernel space is nothing but operating system. User space is nothing but apart from operating system, whatever the applications we are going to install, tools we are going to install, they all come under user space. Clear? Understand? And when we talk about monolithic kernel, Linux is not like this. Everything will be there within the DVD. So you can install the entire operating system, okay, using that DVD, and you will get everything with the operating system. This is one of the biggest advantage when you go for Unix and Linux. And no need to install Office also. You will get the Open Office free of cost there. Acrobat Reader free of cost there. But you can use all these things only in graphic mode. But if it comes to the command line, you can't use it. So in command line, everything is a text file. Like in Windows, you create a text file, right? The text file only in Linux and Unix, it is just used. Understand? So any doubts still here?
No.
Yes?
No.
No doubts? Jaspal, you have any doubts?
No, I'm new,
Alright.
that's why I'm just listening. I will ask you questions later.
Yes.
Yeah.
So basically, today is our, our first session is going on. So today I'm going to stop here only because we have discussed all about the architecture and the kernel types, and so that's it for today's session. And Jaspal, if you can you join tomorrow also same time? Is it possible for you?
No, it's not possible. I have to plan everything.
Not possible, right? So okay, fine. I will talk to you later. When you're mailing, right? Just mail your number to me so that
Yeah.
I will call you
Okay.
on your number and then we will have it. Okay.
Okay.
Getting it. Hmm?
Can you send this
And
file also to read?
yes, definitely. I will give you. Okay, fine.
Yeah.
So that's the
Okay.
thing, right?
Yeah.
Okay.
My
See
number is
you then.
already there in my mail. If you check my mail, there is my number already.
Yeah, if you don't mind, can you send because I am having so many. Okay,
Okay.
no problem. I will check my issues. Hmm?
Okay.
Okay.
Thank
Hmm?
you. Thank you.
That's it. Okay, then see you. Bye bye.
Okay, sorry. One more thing. Hello.
Tell me, Srikanth.
Yeah, if I press the stop recording, is it going to save automatically? And
It is going to save automatically after you leave this meeting. It will be stored this recording in my documents.
okay.
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 You
So
can just
can I play
and
with?
Srikanth, yes, and Srikanth, from tomorrow we are not going to join at 8 o'clock. You have to join me at 7 o'clock only.
Okay, that's fine. It's not a problem for me.
7 o'clock you have to join,
Okay.
and that's it. Okay.
Okay, that's
Fine.
okay.
Yeah. Done.
Thank you.
Okay. Goodbye.
Bye.